And in this project, I'm going to be building this 4-channel remotely controlled ornamental lighting switch so that I can control all the different lights outside of the RV with one of these little remote control units. And that way I can be inside at night and turn the lights on and off without having to go outside. And like I do with a lot of projects, I've assembled everything that I'm going to need. And you can get a detailed bill of materials and other information from the webpage. Also, you can download a document that I have been providing with my latest projects, showing all the salient characteristics that you might be interested in. And I encourage you to download this if you're going to work on the project. Now, the basic heart of the project is this right here. And this is a 4-channel receiver. And essentially what it does is there are 4 relays here. And you have a little transmitter that A, B, C, and D, when you select those buttons, it will turn on one of these relays. And that's basically the whole gist of this project, is I'm going to turn on one of 4 channels that are connected to the various lighting circuits. This is a 315 megahertz system, and you can also buy a 433 megahertz system. Now the 315 megahertz system, that's the same band that a lot of garage door openers use. So conceivably you could get some interference from those. With the 433 megahertz system, you're not likely to get as much interference, but the range may be slightly less. One of the other big issues is the relay current. Now these relays here say they will handle 20 amps at 120 volts AC. So this should be all we need. However, when you look at the back of this and look at the traces, I calculated that maybe they can handle 3 amps. Even though the relay itself can do 20, the board can only handle 3. So I need to drive a much more powerful relay. And this relay is rated at 20 amps up to 240 volts. This is going to handle the current of each one of the channels just fine. And 4 channels, I have 4 relays. And now I encourage you to go to the website if you're building something like this and take a look at where I bought these things, because you may have a hard time finding these. And I also need to supply DC power to this. One of the issues with a switching supply is that it's more noisy. And what I mean by noise, I'm talking about electrical noise. I tested this particular receiver board with a switching supply and it doesn't interfere with it. And again, on my website, I'll put down the source where I got this. Because if you're going to use a switching supply, I would encourage you to try to buy this one. This is around $8 or $9, I think. And I got a little waterproof switch with a little boot on here. I'll put on the outside. These are the standoffs that I will put through here, like so, and then that allows that to allows that to be raised up from the bottom. I don't know that I'll need it, but I do have a little antenna. This is a 350 megahertz antenna. I may mount to that. And then, like I've done on some of the other projects, I've got these little cable glands. And I bought these for like $2 a piece. And it's a whole lot easier to buy these than it is to try to drill some big holes in this case. Because I still want to kind of make this case a little bit waterproof. And these are waterproof rated. Well, when all is said and done, I ended up making 2 plates. This is the original steel one. And then I had some fiberglass, so I made the lower plate out of fiberglass. So this will go to the bottom, and this will go above it. So some of the components I'll mount to here, where originally I was going to mount to the back side of this. Now you don't have to use fiberglass like this. I just happen to have this. You can order another steel panel and replicate that for the bottom panel. Now again, I'll have a dimension drawing of all these holes, and so this is probably going to be the most difficult part about the whole project, is cutting these holes out. And now I'm going to start off by installing these relays in the bottom chassis, and I'm going to do that with some pop rivets. There we go. And then finally we secure the terminal strip to the bottom chassis. And now I have the top board finished. Both circuit boards are in there nice and secure. So we mount the bottom board in here. And then we're going to use these standoffs. And then we'll just test fit the top. And make sure that we have clearance. I did have to rearrange things slightly from the original plan, and I've updated my drawing, of course, to reflect that. Again, here is the bottom. And I drilled 4 holes for these cable glands, and the pigtails for each of the circuits are going to come out here. And then on the front side, this is going to be where the input pigtail is going to be. I've got a circuit breaker that goes in here, and I've got a switch that goes in here. And now I've completed the bottom chassis wiring. And this wiring was just too complex to give you a video of every little step, and then the video then would end up being an hour long. So again, go to my website. When you download the documentation, you'll see several steps here that shows, for example, the installation of the switch and where the switch goes wire-wise. And then we have the installation of the long power cord and how that's connected and how it's terminated. And the connection of the 4 short cords for the output power. And again, shows where everything goes. And then finally, some extra wires that are going to be required in the next step. So in each one of these cases, it shows the wires that you have to make, what gauge they have to be, and so on, and how to wire them. So if you follow each one of these pictorials, you should have no problem at all in wiring this. And we continue on with the wiring with the upper panel. This is the front side, and of course this is the back side. And from the instructions that I generated, here is the back side, page 1 of the front side, and page 2 of the front side. And step 1 of the final assembly, by looking at this page, we wired all the components below the main chassis here, and that just works out better. So now we'll just put some screws in here, and then we have these last 4 to connect, and that is according to our last document here. And so now finally we will do what I like to call the smoke test. So we turn this on, and if we see smoke coming out of it, we did something wrong. So turn power on. Got the little LED showing that it's working. Take our transmitter, and I can hear all 4 relays. And 50 milliamperes is all this is taking at this point. So now we'll just take a sample test load, connect it to channel D, and take our transmitter, push D, and there we go. We've got a set of string lights, and our load went to almost half amp, from 50 milliamps to 500 milliamps. This is the antenna, so we should probably deploy that. And unless I need the range where I have to put in another antenna, I'm just going to kind of lay it along inside here like that. And here's the completed project, the 4-channel ornamental light outdoor switch.